Assalamualaikum and salam sejahtera to all. The topic I will be sharing today is design of reinforced concrete beam, specifically on the type of material properties. I would like to emphasize that I would like to emphasize that understanding reinforced concrete material is very important. I give example. If you like someone, you would like to know his or her behavior and the attitude, right? Same goes to reinforced concrete. We are familiar with reinforced concrete and we can see it around us. Reinforced concrete is a composite material because it has more than one material. So in reinforced concrete, we have concrete and also steel. Concrete is known as having a greatest compressive strength, but it is very weak in tensile strength. Meanwhile, for reinforcing steel or steel reinforcement has a higher tensile strength. In order to capture tensile strength of concrete, we have to put steel. Other than that, concrete is very durable and resistant to fire. Unlike steel, it is very susceptible to fire and corrosion. That is why steel must be embedded into concrete by providing sufficient concrete cover. By having these two materials together, an economical structure material can be achieved. Now we look at one by one material in reinforced concrete. First, we have concrete. I'm sure you are familiar with concrete. Concrete mature at 28 days, and normally that time we measure its strength. To measure strength of concrete, we can use cube or cylinder. We have to bear in mind that in design using Eurocode, the strength is measured using cylinder sample. So if we have a cube sample, we can estimate the strength of cylinder. We call characteristic strength of concrete as FCK. Normally, we call class C2025, which refer to 20 Newton per millimeter square for cylinder strength and 25 for cube strength. Sometimes we also call it as a grade concrete. Table 1 provide concrete strength class measured in cylinder and cube sample. Modulus of elasticity of concrete is also presented. When we tested concrete cylinder under compression, we not just at maximum compressive stress, but also we know how the behavior when the concrete fails. Normally, we can assess behavior through plotting a stress trend diagram. If you see in figure 1, it is the stress strain curve for concrete. When we apply load on concrete, the ratio of stress and strain is almost linear, and this is mean that concrete is in elastic state. At elastic state, when we remove the load, the material can go back to original state. When we continue putting the load onto concrete, the curve will become no more linear. At this stage, behavior is changed from elastic to plastic. In plastic state, concrete cannot return to original state and the deformation is permanent. At a point where the concrete crushing, the strain of concrete is in between 0.002 to 0.0035. Therefore, for all concrete class where concrete strength less than 60 Newton per millimeter square, the ultimate strain of concrete is taken as 0.0035. This value is very important because we will use it in design. For steel, we use terminology of FYK as its characteristic strength. The yield strength of steel is 400 to 600 Newton per millimeter square, and the behavior is plotted in figure 3. Commonly, we use grade 500, meaning that it has a yield strength of 500 Newton per millimeter square. We have three types or three class of high yield bar, which is class A, B, and C. Class A is for bar size less than 12 mm. Class B is for bar size more than 12 mm, which commonly we use. And lastly, Class C is for the earthquake design, where it has a higher ductility. Partial safety is an important factor need to be included in material as well in action. We cannot take exact material strength or exact action without include its safety factor. Table 2 shows the safety factor for concrete and for steel, as these two materials comprise in reinforced concrete. For concrete, the safety factor is higher than steel. For normal design, we use a persistent and transient design situation. That's why we get the safety factor for concrete 1.5 and safety factor for steel is 1.15. Safety factor also applied on action, both for GK and QK. The term favorable and unfavorable refer to the effect of action on design situation. As for your knowledge, here I provide example for both favorable and unfavorable. If you have a continuous span where it has to be designed for larger sagging moment, it will have to sustain any action that can cause increased bending moment. That will consider as unfavorable. In contrast, any action that have reduced bending moment, we consider as a favorable. Normally in design, we use term unfavorable, which give the worst condition. Normally we design, our design action is 1.35 GK plus 1.5 GK. Design action with include safety factor is very important. Normally, we multiply characteristic action like GK, QK, and WK with safety factor we discussed in previous slide. Why we need to multiply with safety factor is because of many reasons such as error in the analysis or design, maybe there is a construction inaccuracy, and possible load increase in the future. By multiplying with safety factor, our design load will become increased. Now we look at more critical part in determining for each material what is its design strength. We use formula of design strength equal to characteristic strength divided by safety factor. For ultimate design compressive strength for concrete, we divide characteristic strength of concrete with safety factor of concrete. We know that FCK is a concrete characteristic strength at 28 days old concrete. We cannot this value solely. This value should be multiplied with 0.85, which this is the coefficient that take account the difference between the bending strength and cylinder crushing strength. As discussed in slide 10, safety factor for concrete is 1.5. So when we divided 0.85 FCK with 1.5, our ultimate design compressive strength is 0.567 FCK. As for steel, the ultimate yield stress is Fyk divided by 1.15. Later, the value of Fyk we will substitute with the yield strength of steel, which commonly we use 500 MPa. So for design yields, tensile stress for steel is 0.87 Fyk. To sum up this topic, it's important to all as you can get some understanding how this material which is concrete and steel behave. All the value discussed in this slide is used to determine the formula for design concrete structure. Before I end up this video, please let me know if you understand the explanation I just gave in this video. If you understand, please type yes, I understand. And if not, or if you have any question, please type your question in the comment section. I'll see you again in the next video.